All right, well, hello everyone. Thank you so much for attending. Also, thank you to the people managing this conference for accepting my abstract. I'm really happy to be here because this isn't so much about me teaching you guys what we think we know. It's rather this is in the context of I want to understand what you guys know. I'm looking forward to your feedback. So the topic of this talk, facilitating knowledge sharing through spatial knowledge graph interoperability and dependency management. This concept originated out of our work in the digital public health space, focusing on lower resource settings. And so we found ourselves implementing this approach, and we decided, okay, well, let's actually write this down, what we're doing. And so if this approach is useful, then that approach should take its own life cycle. It should stand independent of our tool, and then our tool, our open source tool, which I'll get into here in a bit, should then be influenced by the direction of the approach as it's being validated by experts like you guys. So a little bit of background about myself. I have a master's degree in computer science. My company TerraFrame has been developing solutions that are open source. We got started in the disease intervention and elimination space a number of years ago. And what we started developing back in the early days was a process for managing what we called back then geo-ontologies, which you can now say is sort of a proto version of what we now know as spatial knowledge graphs. We started our initial work and got our funding from the Liverpool School of Tropical Medicine in Liverpool, England, to build open source solutions that would integrate disparate data by location to give decision makers the ability and visibility into where the problem spaces are for disease and whether interventions are working. But when I say integrate data by location, we're talking about a spreadsheet containing a column with a village name that may not necessarily have a standard spelling in the Latin character set. So we ended up developing some ontological models and inferencing algorithms to try to automate the normalization of location data as they're represented differently across other systems. The tool I'll be talking about is sort of the latest incarnation of that technology heritage. It's called Geoprism Registry. It's a recognized global good in the public health space, meeting the criteria for sustainability. That includes configurability. Is it localized? Is there documentation? And to what extent is it gained traction? So we're also leveraging this technology and other spatial knowledge graph principles for an application for geoplatform.gov called the Imagery Data Manager. So we use spatial knowledge graphs to manage the relationships between raw data, sensors, platforms, and now location to enable some enhanced querying capabilities. So I'm excited about this talk because this topic has already been covered in some other sessions, but that is that the United Nations Committee of Experts on Global Geospatial Information Management is saying that nations need to move beyond NSDIs to geospatial knowledge infrastructure because the ecosystem of stakeholders and the people who would benefit from geospatial information has greatly expanded beyond the initial group of geospatial professionals. And that data as a standalone asset just isn't as valuable as it used to be. So we need to move beyond data-centric solutions to knowledge-centric solutions because as this document, as well as others published by the UN and the WHO, that knowledge sharing is needed to address critical problems facing humanity, economic, societal, public health, and of course, environmental. So the UN Integrated Geospatial Information Framework outlines the need for collaboration across different kinds of entities, federal entities, private sector, nonprofits. So how do we collaborate with knowledge, not just data? I think part of the problem is we're living in an age where our data management tools are incredibly mature. They're well established. The processes for managing data-centric solutions are well known. But when it comes to knowledge management and specifically knowledge sharing, we're in the nascent phase right now. I think we're still all trying to figure out what that means and what's the best way to do that. So in this talk, when we talk about facilitating knowledge sharing, we're talking specifically about spatial knowledge graphs. Not that this is the only way to facilitate knowledge sharing, but this is a very good way. Because knowledge graphs are a great data structure for representing large model networks, semantic properties. And so if we start to model knowledge using knowledge graphs, wouldn't it be great if we can start integrating those knowledge graphs between different organizations in a much more automated way, machine-to-machine readable, to facilitate that cross-sectoral collaboration. But knowledge sharing requires interoperability, and interoperability requires semantic standards. Now, unlike things like terminology services that facilitate interoperability by taxonomies and ontologies, if we think of location and location hierarchies and graphs as a semantic standard, one key difference is when it comes to terminologies, they tend to be curated by some sort of international organization. In public health, you have something called SNOMED, LOINC, ICD, and so forth. So there's this large overarching body that is establishing these standards, but for location semantic structures, they tend to be more contextualized at the local level. So we'll talk about, and I want to get your feedback for how do we curate those hierarchies, those local graphs that capture that localized context and make them interoperable. So we'll be introducing just a little bit of terminology here that's come from our work in the public health space. So when I say geo-object, I mean a feature in the context of a spatial knowledge graph. So a geo-object you can think of as a node representing a location in a graph, and then edges capture some sort of spatial semantic property between locations. And then a geo-object type is sort of the formal definition of the type of that geo-object. So this is becoming more and more relevant because fairly recently, large language models are now in the media, and it looks like that people are going to be getting more and more information from them, but they have some significant shortcomings. They don't model explicit knowledge very well. They tend to hallucinate, which means they seem to derive information that just doesn't exist or is blatantly wrong. Results tend to be a black box. You can't trace back to figure out how the LLM came to that conclusion, and they lack domain-specific knowledge, and they're also not very good for incorporating new knowledge in a more dynamic way. Well, that's actually the latter is what knowledge graphs are very good at. They're very good at capturing those domain-specific properties and are a great data structure for incorporating new knowledge much more frequently. And so knowledge graphs are relevant because, I'm going to ask a rhetorical question here. For those of you who work for federal agencies who curate data, you guys are the authoritative mandate for certain types of data. The question is, would you rather have these LLMs have access to the result of your work because you guys are the experts versus having LLMs as sort of deriving from unstructured text some sort of answer which may or may not be relevant? And so if we could publish our domain-specific analysis in the form of spatial knowledge graphs, then ideally these LLMs would be able to utilize them and just benefit society in general with much more accurate information. So I'm going to talk about some challenges to FAIR when it comes to sharing knowledge using spatial knowledge graphs. And then after my presentation, I'm very curious to hear what you guys think are some of the challenges you face. So when it comes to findability, so one key difference with modeling knowledge and spatial knowledge graphs is they tend to be individual object centric versus a feature class or a database table tends to be more data set centric. So just, for example, finding in an ecosystem, show me everything that exists or has been collected for this particular location is normally an exercise that takes quite a bit of time. If I want to find out if there's data on hydrography, transportation, population for this particular location, as a general rule, that's not an easy exercise. Accessibility is also can be a challenge. So if you look at ArcGIS knowledge, they utilize Neo4j and they facilitate the creation of these spatial knowledge graphs by incorporating data from the Esri stack. but they're treated as a means to an end. The Esri knowledge graphs are not something that are published in a way that is publicly accessible and findable across the ecosystem. They're a means to an end, whereas the ArcGIS data model is, the existing one, is considered the authority of record that is shareable, not the graph. So when it comes to interoperability, there are a number of challenges. A key one is establishing semantic identity for the same location. So I'm aware of some spatial knowledge graph efforts where organizations have gone to different government and other non-government sources, pulled in a lot of data, but within their graph, they may have the same location represented as 3 different nodes because they pulled from 3 different data sources. And there was no way to automatically establish semantic identity. So even though they've pulled in all these different data sets, it's not necessarily answering the question, show me everything that's associated with a particular location, because that location can be represented multiply, have multiple representations within the same graph. So it's almost like a graph that within itself contains microsilos. And reusable. If I publish a knowledge graph as a first order object, to what extent can you incorporate that graph into your work while minimizing the amount of effort to clean it up and make things interoperable? Ideally, earth scientists should not be in the business of writing software or cleaning up a lot of data. In an ideal world, that should be automated as much as possible. So now I thought I could talk about our experience in the public health space. So I'm going to talk about this problem from the bottom up to share with you the perspective that we've obtained from our work, from our experience, and what led us down this path. And then, of course, I'm curious to hear what you guys think, how this approach would apply to your work. Like I said, we got our initial funding in the public health space. And so it's very important to bring data sets together from different sources to answer questions like, where are the biggest problems? Are interventions having the biggest, are they having the impact that they could have? What's our vaccination coverage and so forth? But what the public health sector is finding out more and more, it's not just important to integrate data that pertains to health for the sake of health, that data outside of the health sector is just as relevant as data within the health sector, such as environmental data. So what makes this problem a challenge, and I think you would agree this is not limited to public health, is that each information system tends to have a different representation for the same geographies. And because they have a different representation, and this could be in the form of not having consistent IDs, and then if you rely on spelling, obviously that's a disaster, especially when in a lot of countries, there isn't a standard Latin spelling for indigenous names. And so this prevents these data from different sources to be brought together by location in a machine interoperable way. Another challenge is that these systems tend to support one location hierarchy. So a hierarchy really is a subset of a graph. A hierarchy is a graph. And so that's, as we were trying to address this problem, we realized that, wait a minute, we should not just think in terms of location hierarchies, we should think in terms of directed graphs, undirected graphs, and so forth. And so here are some acronyms that are very well known in public health. MOA typically stands for Ministry of Home Affairs. They are responsible for the administrative hierarchy or the political hierarchy. These hierarchy types are inspired by the Tolkien books, and these are the types that we use in our demo server. In case you're wondering why Shire is up there. MOH stands for Ministry of Health. So you'll have Ministry of Health geographic hierarchy. You might have a Ministry of Health operational hierarchy. But the problem is these systems have dependencies with graphs that they do not curate. And so what typically happens is this data is pulled over, it's stored, and it stays stale. And in public health, one of the big ramifications of that is, in some cases, entire communities get passed over when it comes to vaccination campaigns or other types of interventions. And so another thing that really makes this challenging is locations, hierarchies, boundaries. They change over time. You have administrative divisions that split, merge, combine over time. And so this is typically not captured in metadata. So if I have programmatic programmatic data captured for 2020, but I'm using boundaries from 2018 and 2019. We had a division split. If I'm not aware of that, then my spatial analysis may be wrong. Maybe I catch that, maybe I don't. But the temporal aspect is typically missing from metadata. So we got down this path by being selected to be the first implementers of a concept called a common Geo Registry that is being endorsed by the World Health Organization in the public healthcare setting. And the goal of a common Geo Registry is to facilitate a single source of truth for geographic data and hierarchies as they change over time. It's the role of a CGR to manage location identity, classification, geometry, and relationship to other geographic objects, and that's it. It's not the role of a CGR to be a geospatial data warehouse. It's not the role of a CGR to capture domain-specific attributes like population. Well, whose population? Population for taxation or population for disease intervention? Yes. I see. That's where the answer is yes. Oh, and the bottom. Thank you. I'll let him do it. Thank you.
Hide video panel.
Oh, one down.
Awesome. Thank you all for your help. Appreciate it.
Thank you. And let me know if there's someone asking a question in the chat. Okay. Yeah, and so a CGR, the goal is that across sectors, if all information systems have the same representation of geographies for the same periods of time, then you can integrate data by location in a much more automated way. And so, yeah, in the recent release of the WHO Geo-Enabled Microplanning Handbook, they identify this concept of a common Geo Registry as a foundational aspect for intervention and for microplanning campaigns. Okay, so our implementation of the CGR concept is called Geoprism Registry, and how we have implemented a single source of truth and dependency management in a multi-tenant architecture across different organizations as we use a spatial knowledge graph. We have one geo object or node for each object, and the organization with the authoritative mandate is responsible for maintaining the state of that object and also geographic relationships between objects within their own hierarchies. And then we also allow for organizations to subscribe and establish dependencies between their hierarchies and other hierarchies. So the idea is in an automated way, as these dependencies are changing for the correct period of time, then those changes propagate automatically. That the timeliness component is captured, so you know as changes are being made for when they were made, and I'll talk about some important details about that time component in a bit. We also keep track of what we call historical events, splits, merges, combines, upgrades, and so forth. So that can be modeled in the spatial knowledge graph. What do we do with it? Nothing. The idea is that it's recorded in a way to where, through the API in the ecosystem, other systems can query, what was the history of this location? What was this thing 5 years ago, and so forth. And also on that temporal component, something we discovered is very important and took us a while to implement. It's, when we talk about period of time, it's not when the data were updated, it's for when the data were valid. But that also changes. So in the case, and this is very important in the healthcare context, let's say you have a facility registry, a list of all the health facilities in a country relative to the administrative hierarchy. You can model in the software what it looked like in 2010, but we also make the distinction between what it looked like in 2010 as we understand it today, and what we thought it looked like in 2010. Because what we had in 2010 was actually incorrect. Those errors have been corrected, but we need to preserve what it looked like back then so we can reproduce the analysis that were done and to justify the decisions that were made and so forth. So, very important distinction. Okay, so this is a super abstract simplified visionary slide. So the idea is, yeah, if we can publish our work in graph form, and they all refer to the same geographies, the same representation of these locations, then you could combine, in this case, flooding model, a transportation model, and a population model. You can chain those together in a much more automated way, and the blue sky vision is that just happens automatically. Obviously, this is a challenging problem, but that's at least the vision. So that as we want to incorporate knowledge from other organizations, that we're avoiding the need for a massive data integration exercise that may end up preventing us from doing the work in the first place. So what we're calling for now, unless you guys tell us this is a bad label, we're calling this approach a spatial knowledge mesh that's inspired from the data mesh architecture pattern. It's really more of a specialization. The idea that it is cloud native, and we've identified these properties that are needed for a spatial knowledge mesh to automate the sort of interoperability and the dependency management. Number one, there needs to be metadata that captures the authoritativeness of the data. So as data are being copied, as graphs are being copied from one source to another, that the authoritative source always is preserved versus having data sitting somewhere in some data structure and you don't know where it came from because whoever was managing that has left your organization. The authoritative source is always preserved. And then the temporal component, again, this is not when were these changes made within the database, this is for when are these changes valid. So in other words, this graph is valid from 2000 to 2005, and that follows the information no matter how many times it's copied. Distributed, so we're leveraging the data mesh approach because one of the challenges of a centrally managed IT solution is that, like a geospatial data warehouse or a data lake, is that the central IT team, they are not domain experts in the data that they're managing. And so in the case of a geospatial data warehouse, what can happen is that in order to fit everything into a common model, you have stuff lost in translation. Because again, the IT team, they're trying to create a single model, but as my graduate professor told me, that this has always stuck with me, one man's abstraction is another man's junk. So the abstraction that the domain experts created may not be serving the same purpose as the abstraction that the IT people are trying to create in the data warehouse. And then of course, versioning. So it's not just for what period of time is this valid, but what version? So you may have data that's valid from 2000 to 2005, but that might be version 5 because errors were corrected and so forth. Another property we identified is this should ideally be transitive, which means that if you have an organization A, that curates and publishes a graph that is then used as a dependency with organization B, and that organization C subscribes to organization B's graph that contains A, that A should automatically propagate. So that as changes are being made to A, that in an automated and machine readable and controlled manner, that information can automatically propagate to C if that's what they desire. So C is at least aware that dependencies that they are leveraging have some updates. It should also be interoperable by common geographies. So again, if you have organization A has published a graph, and it is a dependency for organization B and C. If organization D subscribes and pulls from B and C, that you don't have duplication of A's data. And on top of that, which isn't captured in this slide, is if the timeliness of the data from A on B and C are not compatible, that at least should be flagged. That the organization D should be aware of that the temporal aspect is not necessarily compatible, and then they can decide what they want to do from there. So this is a high-level diagram to communicate how these different components in a spatial knowledge mesh would interact. And for those of you involved in the discovery cluster, you've seen some version of this before. So you may have heard me say or use terms like pull, merge, publish, and now you see something in there called a graph repository. If you're thinking, well, that sounds like a code repository, and you're absolutely right. That's what we kind of discovered that we were building, not intentionally, but as we were trying to solve these interoperability problems for hierarchies in public health, it looked like we were building this notion of a knowledge graph repository that would keep track of dependencies between graphs curated by different organizations. And so the idea here is that organizations can publish their graphs for different periods of time and for different versions, and that other organizations can subscribe to them in a controlled manner. If new versions are being released, that through APIs and metadata, that the ecosystem is then aware. And then you can decide, okay, I'm leveraging a graph from organization A. It's the new year. They've published new data for that year, a new graph for that year. Now I can pull that into my model, and I'll have the version from both the past and the present one. And now I can run my analysis and do time series if desired, or whatever it is. So the idea is that we're just managing these dependencies. What the organizations do with this information, that's up to them. They can do it in whatever kind of tool, but we're focusing on the semantic relationships, semantic identity of the geographic data. So I covered this already, that we're leveraging the data mesh architecture pattern. It is distributed, and it's also should facilitate this transitive property. If you guys have a coding background or ever used like dependency management tools like Maven, the idea is if I do Maven update on my project, library A might be updated, but then library A has a dependency on library B, which has also been updated. So even though I'm just doing an update, that all of those dependencies are updated as well in this transitive fashion. And then the common Geo Registry concept, again, so even though we have an implementation of this concept, we're trying to promote the ideals of the CGR. We'd like to see other people implement their own version or their own vision of how a CGR can operate, because we're very much a believer in this concept. But the idea is that you need something facilitating interoperability, and that's definitely true with the data mesh pattern. Is if you're going to give people the ability to subscribe directly from the source, there needs to be some interoperability layer, so that as you're pulling from different sources, that each pull is not a separate labor-intensive data integration exercise. And so what a CGR does is it facilitates that authoritative property, which is necessary, the temporal part, the period of validity, the versioning, and it's setting the semantic standard for these different semantic properties in a graph. And again, the goal is that we're envisioning that, well, the advantage of this approach is that in order for it to succeed and really be impactful, it has to work at the local level. So how do we curate semantic hierarchies within local contexts? Because that's currently missing. And then we all know what a terminology service is. And then we have this notion of the spatial knowledge graph repository that takes care of, again, addresses the temporal piece, the distributed piece, and manages versions. Okay, so this is what it looks like within the spatial knowledge graph repository. This is how we implement it. So you have your geographic objects, so one object per location, and then for these semantic relationships. In this case, common one is just located in, but it could be downstream from, flows into, flows through. It could be, whatever the semantic property is. You can model them as edges, but those edges have a time component for when they're valid. So in this case, we have District 3 as a child of Forest 2, but District 3 is a child of Forest 2 from T0 to T1. But at T2, Forest 2 combines with T1, and then between T2 and T3, District 3 has a new parent, and that's Forest 1, because its previous parent combined with it. Does that any questions here? Does that make sense? Okay, good. And then when it comes to publishing graphs, so right now we just have support for publishing hierarchies. We haven't started directed acyclical graphs or undirected graphs yet. The idea is, okay, so we're managing all of these relationships in the graph, and what got us thinking all these lines is one of my developers came to me and he said, I know we're using a graph database because a graph database is lightning fast and can model hierarchies orders of magnitude greater than what you can do in a relational database. Because in the past, we would have to jump through all sorts of hoops and do a number of different kinds of tricks to get a relational database to model hierarchical data. And he said, the problem is, as we're storing the time component, we're sort of negating the benefits because in a graph database, unlike a relational database, when you do a join between your primary and foreign keys, you have a B tree index, and it's lightning fast, but as the data are growing, it's very common to have a query that was fast yesterday is now slow today because the tables are 10 times larger. Graph database works a little differently than that the edges connect these nodes in a much more direct internal ID fashion. So there isn't a join, it's just a direct traversal. But he said, we're always querying the time component because in our software it'd say, what did things look like at this period of time? And then we'd traverse the graph and do the temporal queries. And he said, we're slowing this down by an order of magnitude. And it's not really, it's fast, but it's not that fast. And I said, okay, well then maybe, that's when the light went off in my head. Okay, then what we've really built is not the graph that people do their analysis against, it's the graph repository concept. And then from that, you can publish graphs for different periods of validity. So the temporal component on the graph to the right and above is on the meta definition of the graph itself, whereas the temporal piece is tracked at the attribute level, the geometry level, and the edge level. For the graphs that are published on the right, that's on the metadata of the graph itself. And one other thing I didn't mention is on these nodes, we're actually storing the geometries as well for a number of reasons, which we can get into later. So there are a number of benefits to storing or creating edges in a graph that represent spatial properties that you can derive from geometries. One of them is performance, but also, especially in public health, the geometries are not always accurate, so we can't rely on them to establish these kinds of relationships. And so once these graphs are published, what we've recently done is for that drone data management app that I'd mentioned earlier, it is subscribing to these published hierarchies from Geoprism Registry, so that within that app, the app can organize raw imagery, process imagery, and so forth by these operational hierarchies from US Forest Service, that it is not becoming a silo of this. We don't have that app is not responsible for maintaining these hierarchies, that they can just simply subscribe to them and will receive updates as they change over time. Does that make sense?
This means that time has to be very discrete.
Yes. Okay.
So I guess this means that time has to be quite discrete. Like you can't have something change midway through year, T0 and T1. You have to say, I'm going to make a snapshot at different periods. You have to know what those snapshots are, right? That's,
yeah.
I mean, this is an ingenious way to simplify it, as long as it's not too simple.
Yeah, so I'm jumping ahead a little bit in my slides to address that. So within the repo, so here we have repo 1 on the left, and within a year, the name of a location has changed 3 times. Okay, great. But then you can decide, I'm going to now publish a graph for that year. It's valid for that year, but which value do I use? So you can decide which value you use. So even though it may have changed 3 times from an official standpoint, that might have been internal, internal management or whatever, right? It may not be relevant. So you can choose, if I'm answering your question, hopefully I am, that you're not just publishing for a period of validity. You can say, okay, but a period of validity, but from what date in the repo are you driving that from? If that makes sense. And then, so we haven't implemented the merge part yet, but the idea would be that as this published graph is merged into someone else's repo, then the 3 values on the left, they wouldn't even see them. They wouldn't even be relevant because they're not the official values. So. We don't have to spend a whole lot of time here. So we have in the architecture a meta model facade. And so we have the API to that documented. So the idea is that you can create a geo-object type, you can create hierarchy types, you can define how they relate to each other, you can define DAGs and undirected graphs, you can define attributes, and you can do this all at runtime. So as you define this through the API or through the GUI, we're generating all the database tables behind the scenes, we're defining the metadata on the graph to make that happen. So it's dynamically configurable. This may not be of a whole lot of interest. This is more the meta model underneath the hood. So this is based off of some of our existing work for developing decision support systems in the disease intervention space. So we have this notion of an MD class. You can define attributes on a class. You can define an MD entity, which means that's a database table. So in public health, what we do, this is being done in Laos currently. The idea is that instead of what we started doing, instead of publishing graphs, we were publishing tables. So we're saying I'm publishing a list and I'm selecting which parents from the different hierarchies that this object type participates in. And then for that period of time, you can specify what's the frequency. Am I generating it for on an annual basis? Am I generating for a specific date and so forth? And then the graph is sort of queried and said, okay, finding what everything looked like on that particular date and then publishing a table on Postgres, which then can be consumed because we still live in a tabular world. But then we extended that metadata, and so we introduced the notion of a geovertex. So a geovertex defines a geoobject type, and an MD edge defines different edge types in the model. Again, this all can be done at runtime. Already covered that. Okay, so future work. Like I said before, we have not implemented support for graph merges. There are a lot of questions there. In the discovery cluster, as we were talking about this merge concept, someone said, merge? Do you realize how big these graphs are? You're going to pull over everything? I mean, that's going to really explode your storage. And so then we thought, well, okay, well, what about this notion of a symbolic link where we're not necessarily pulling over everything? You know, what do we have to pull over? Pull over enough to where we can establish a relationship between my graph and the dependencies. We don't know what that looks like, but that's just still conceptual. Looks like what I don't have here is also the notion of, should pulls be done at the local level? It's not just pulling over symbolic links for everything. What if I can just say, hey, I'm only interested in your model for this county. Your graph may cover the whole United States. I don't care about that. My research has nothing to do with that. All I want is your model for this location. Do we incorporate that into the abstraction? And also an important distinction here is, I have here this third item, support for publishing to RDF triples as products. You're like, well, what have we been talking about? Well, so there are label property graphs and there are triple stores, and they each have their own advantages. We're using label property graph. We're using OrientDB as the open source graph database because of its support for spatial. Label property graphs are better for maintaining state for objects. If you're doing analysis, there are a lot of advantages that triple stores have. So we are publishing currently 2 tables. We are publishing now label property graphs. We are not publishing to triple stores, which I think that would be really interesting. How would you conceive that in the metadata? How do you decide what properties in a labeled property graph would end up at a triple store? So just real quick, like in a triple, you just have subject, predicate, object, that's it. So if your location has 3 attributes, that would be 3 triples, versus in a labeled property graph, you just have the 1 object with the 3 attributes on them. Ultimately, we need more test cases to demonstrate if this approach lowers the time to create a shareable knowledge product. It leverages products from other organizations. So that hopefully communicated kind of where we're coming from this. And now I'm really interested in hearing from you guys what your thoughts are on some of these topics. So I'm now hopefully seamlessly go over to Slido. So I'll give you guys a few minutes. So how about this? I'm making the assumption that some of you guys work together, and if you guys work together, you probably are sitting close together. If not, that's fine. But if you guys can break up into groups of like 4 or 5-ish. And the reason why I say, let's see if this works. You guys work together? Because I figure you guys are probably working on similar problems. And so I thought it'd be good to discuss and then post here what are some of the knowledge sharing use cases that would be relevant to your work. And then I thought after that, I want us to talk about what are some of the challenges to FAIR in order to achieve those. And then to what extent do you think our approach could help that? Well, what are we missing? I really want to hear from you guys. So we'll start with this poll. And so do the answers just show up here? Or? Yeah, you should. Okay.
You're collaborating now?
Yes, sorry. Yes.
It seemed very quiet for the collaboration.
You seem better. Okay, perfect. Give it a couple more minutes. All right.
I try to make the room look full.
I'm sure they're fine. I'm sure they're fine. Awesome. Okay, any other ideas for data sharing? Knowledge sharing, I should say.
understand how corporate knowledge process of understanding. Yeah, I think that we're just allowed to do multiple responses. Well, it's also it's actually usability, and like so like within the organization, you are often aware of the file outputs, but you don't know the stuff that they did to get to that output. And often the thing you want to share is not the final output, it's the process along the way. And so the kind of capabilities that people have to get to final outputs are the things that you want to share the knowledge of. So although something
Got a couple people typing, and after they post, we'll move on to the next question.
That's also called know-how.
Yes. And so you notice that other people are also doing that.
Oh, I see.
But you don't know that they're also doing that because that part of their team is invisible.
Okay, that's very useful. Okay, one other person typing. We'll move on to the next one. So the next question within your same group, what I'd like you guys to do is spend some time talking about what aspects of the FAIR acronym do you see are the biggest challenges? Now, they don't have to be technical challenges. I think our approach is definitely a technical one, but what is holding people back? Is it because you can't find what you need? Is it because interoperability, overcoming that is just so prohibitive that that's stopping you from moving forward? What do you guys think? How do I show them all? So that'll be the next poll. Does that make sense? What specifically? Yeah, good. I'm going to, I'm going to change that. Yep. And I do that by. Usably by whom?
Some of them in help like using like plant-based DNA, we call the same thing, just like words and
Licensing.
I would say at the moment that as in things vary, I think just how I'm interpreting this question is usually just findability. Like once you know the thing exists, then there's nothing fun where you're like, okay, well that's what that person about. And I can probably start finding some documentation. But then I want to search for
we have the most work on that's relatively easy and problem to solve, but it's still one of the greatest areas.
Yeah, just give it a couple more minutes.
It's not saying it's difficult, I'm saying it's just very, it's just saying it's an area that it's difficult.
Okay.
If people are validating stuff, then because at least you don't have that online, then you might be looking for metadata and gradually things that come together by both describing what we're looking for and gradually connect that.
All right. Well, this is all great. This is all great feedback. Yeah, licensing that's very important because the data sets that we're working with are public by nature. We're not necessarily in that realm, at least not yet. So I'm seeing as big ones data formats, metadata, and here's an example of semantic incompatibility. We have at least two terms: semantic incompatibility, and Slido didn't recognize that they're semantically equivalent, so they're listed as two. Ontologies, I think, also could fit underneath that umbrella. Lack of domain ontologies, okay. So so already this requires a little bit of extra human interpretation. If we're going to derive a quantitative jargon, yeah, exactly, same kind of thing. Okay, so no, thank you for that. Now, this we're coming to the point where this is what I'm looking forward to the most is. So I guess we'll start with questions on our approach and what do you like, what don't you like, what do you think is missing, how applicable is this? Yeah, let's start with any questions on what we're doing and sort of what we're trying to achieve. Jonathan. Oh.
About your presentation before. Yeah, so my question, this is Jonathan Blythe, BOEM. So what I don't understand, and maybe I was daydreaming when you explained it, the graph solution is simply talking about text-based, like well-known text, or is it you have the features in the metadata or the knowledge graph somehow, but how do you do spatial intersections between them using the geospatial features?
Okay.
Is that part of the?
Great. No, that's an excellent question. And so when it comes to, let's pull up a graph, what do these relationships mean? We're just managing what they are. You have to derive them yourself, right? So we're not facilitating, what is the intersection? How do we derive an edge based on this property or that property? The idea is that that's happened externally, but you're actually officially publishing and saying between this location and this location, they have this semantic property. It could represent hydrography. It could be spatial proximity, whatever it is, whatever the label is. You determine that, but then you're publishing that. And also managing the temporal component, because that edge may only exist for a certain period of time. Does that answer your question? No, right.
So following on to that, I've seen a lot of semantic types and a lot of edge types here. Is there some place where we can go to like comment on these or request new terms, or is this at all community driven? How can we get involved in this?
And no, that's excellent. So if we go back to the CGR concept, if I can find the slide. Well, at least where we're focusing our efforts now is for facilitating interoperability on these semantic spatial properties by the organization with the authoritative mandate. So the idea is that the Ministry of Interior, the Ministry of Statistics, they're the ones who are defining their own semantic relationships between their own types. That's internal to them. And so they publish the relationships and semantic types that they've curated. When it comes to something a little more collaborative, as far as what type of edges are being supported in the model, that's not something we've had to focus on just yet. And I don't think we have any magic there, or we just haven't thought about that a whole lot. But regardless, you would need some sort of registry for establishing what those are. So within the ecosystem, those are known. Does that answer your question?
Yeah, I guess that's another no.
It's another no.
There's no place to,
Is there a repository? Is this in one repository?
Yes.
we just can't contribute to it.
So the source code is on the repository. Is published on GitHub.
But not to the vocabulary.
That's right. This is domain agnostic, all metadata driven. So when you install this, there's nothing in there that says, it's being used by the Ministry of Health and Laos right now, but there's nothing in there that says health facility. That has to be defined itself. Or defined by you guys, I mean, the users. So
question, Ryan Berkheimer from NOAA NCEI. So this is really interesting work. I like the derivations of some of the principles. I think, they're fundamental to sort of archive, but this feels very stateful to me. So, in computer sciences, state is kind of an enemy of simplicity, right? It's very complected. So it seems like there's a lot of out of band management of state, to manage that state. So, is there, how do you deal with, other interoperability aspects, maybe, is a question for you in this system.
can you give me an example?
How do you deal with, if I want to know provenance from you, but I don't really know anything about your system, how would I request that? Right.
Okay, I sort of glossed over that, but in the current implementation of Geoprism Registry, for each geographic type, there are a lot of metadata fields that capture some of that. So the idea is that, and Geoprism Registry does have a public-facing interface for stuff that has been published. Oh yeah, and something I think I glossed over to make it very clear is Geoprism Registry, our implementation is not federated, it's not distributed. It's a single instance multi-tenant, but the federated approach is something that we've seen a need for in our work. But to answer your question, that we do have a number of metadata fields that capture some of that.
Okay, so maybe, as a follow-up, I guess what I'm maybe driving at is this Geo Registry approach, I think, is how you're tacked for that interoperability, right? We need a Geo Registry to sort of federate. Right?
Yeah, the common Geo Registry concept for establishing those semantic standards for interoperability.
Yeah.
And then Geoprism Registry is our implementation of that, of that concept.
I just wonder if it feels very SDI kind of to me. The Rosetta Stone approach is, we know that really well in a lot of projects and efforts. And I just wonder, tying this back to your theme, which is the Geoverse, right? It's how do you see that this system that not everybody's going to adopt interoperates with other ecosystems or systems? Yeah. Thanks.
No, that's a great question. So you're absolutely right that it was initially funded to support that NSDI. In fact, it's being used by the National Geospatial Agency of Mozambique for their NSDI. We just happened to, we implemented the graph as an internal implementation detail. We got a lot of pushback on that, like, why is this even necessary? because I'm the architect, so I just saw that that would be useful for dependency management. And then after that, so that's when the light went on and said, okay, well, that could actually has potential to facilitate a GKI, a geospatial knowledge infrastructure. So publishing knowledge in graph form, not just in tabular form, which is typical for NSDI. So if we get traction, that's our hope, is to position the tool that, yes, it can help with NSDI now, but then help transition, really support a GKI, which of course is a very big endeavor and involves a lot of other things. But does that answer the question?
I just have one comment. I think this is a very tractable, an important problem, and we'll learn as we do it. It's not it's perhaps one step along towards something more, a more comprehensive solution. So the Geoverse, we were in a Geoverse session before, has to be built on the SDIs. You can't just start from scratch.
Yeah, so when you say, well, we don't have semantics in here, I can't believe you. And because a lot of what you call semantics, we have a defined term, that's what's known as well-known. Okay, the semantics of an entity in your graph are defined formally by the relations with other entities. And those are in your graph. So the semantics are in your graph. The question is how to get them out and how to operate on them. And certainly one form of geospatial semantics is to say what is in the same place. And you're doing that. So, you are doing important but not exclusive forms of semantics and semantic processing. So I would
Correct.
advertise those and
Correct.
not say, well, semantics, it's up to you, because you're actually providing some capabilities.
But it's up to the users to define those edge types. I see this more as like interoperability plumbing. So, thank you, everyone. And for those who are interested, please follow up with me afterward.